Here's the agenda for today's presentation. We're going to talk about how manufacturing scheduling works within complex dynamic manufacturing environments. We're going to talk about the advanced scheduling solution in general and what an advanced scheduling deployment looks like. Well, let's begin with an overview of these complex dynamic environments. Production environments are inherently complex and must dynamically respond to internal and external contingencies. That's three things. The inherent complexity and the internal and external contingencies. Let's break it down. The inherent complexity derives from the fact that in a modern manufacturing line, the facility must produce multiple products. There may be multiple possible routings per product. Work centers have varying cycle times, and products may have different curing times, cooling times. In the case of food or solvents, different expiry times. And then there's varying setups, teardowns, and cleanouts. So even if your supply and demand are absolutely constant and your equipment is 100% reliable, there's an inherent complexity to getting product down the line and out the door. But supply and demand are not unchanging, and that's where we get into our external contingencies. There is over time a changing mix of product demand and changing product volume demand. This could be due to seasonal cycles. It could be due to secular changes in the marketplace. But a schedule that worked for you in 1 week of 1 year, it almost certainly won't work for you, the same week a year later. Demand is often very demanding in the form of rush orders. And then also there can be unexpected material shortages or material lead times. That's the supply side of the supply-demand contingency picture. And as I had said, inherent complexity is complex enough, even if your equipment and your people are 100% reliable. But unfortunately, there are internal contingencies. There's equipment breakdown. Staffing may be very lean to start with, and then there could be unexpected absences, which result in a work center not being available for a period of time. And unfortunately, the production output might not be 0% scrap rate. So a certain amount of product that you've scheduled to go out the door probably won't, because it either has to be scrapped or there is additional work and time necessary as the partially damaged but still viable part goes into a rework cycle. So here you can see inherent complexity, external contingencies, and internal contingencies, and these drive the need for an advanced production scheduling system. So let's talk about the advanced scheduling solution. It addresses the inherent complexity, external contingencies, and internal contingencies. At the heart of the system is a scheduling engine provided by the software publisher, and it will deal with the inherent complexity by creating a valid baseline schedule. Now, position situated upstream of this is an ERP system, which is sending orders and order amendments to the scheduling engine, also information about material availability or non-availability, as the case may be. The scheduling engine generally passes its schedule back to the ERP system so that salespeople and management know what to expect. And that is how we address external contingencies. Now, you also have typically an MES or SCADA system, which is the delivery mechanism for the schedule. It doesn't have to be. The schedule could be posted on an internal website, and it can be printed out and distributed on paper. But it's ideal to feed it directly to the MES SCADA system, so all the operators and supervisors can see it on their computers and monitors. And so the MES and SCADA system can feed back information about order progress. Just because an order is scheduled to be done at a certain time doesn't mean that it's done. What is done and what is not done? The scheduling engine needs to know that in order to produce, tomorrow's schedule or next week's schedule or next month's schedule. There could also be breakdowns on the shop floor, which once reported by the SCADA system, the scheduling engine, with the help of the production control team, can respond to. So that is the mechanism for understanding what is and isn't happening on the shop floor. That's the mechanism for dealing with internal contingencies and feeding those back to the scheduling engine. So, boy, this sounds like a really great solution for a manufacturing facility to have. What does it take to deploy? Well, here is a version of the diagram that you saw. Again, with the ERP system upstream of the scheduling engine and the MES SCADA system downstream. And here we see the entire scheduling cycle that has to be implemented, that has to be deployed. There is a process of analysis and design that your scheduling solution provider will undertake to discover the in the discovery phase, to understand exactly what the business requirements are and what are the capabilities of the ERP and MES system. From there, functional and technical analysis can take place. The functional analysis is more or less, what do the people need? What does the business need? The technical analysis is, okay, these systems that are humming along in the background, exchanging ones and zeros, well, what sorts of ones and zeros do they need, and in what form and at what timing? And once these things are known, then your APS provider can make a system design, at which point the build phase begins, and the deployment team is going to implement both the scheduling engine and the IT components on either side, and the customer team will test. At this point, we usually deal with one or two subject matter experts on the production control team, and then this is an iterative process. So not only the APS system provider, but also the customer team, the production control team, and the IT team ought to be prepared to invest a significant amount of time in the deployment up to and including launch. And that at that time, all client and server software is installed. Data feeds to and from the ERP and the MES systems are fully activated, and then the system cuts over from the facility cuts over from the old scheduling system to the new. And what is the old scheduling system? Very often it's a set of Excel spreadsheets that the production control team has to spend many hours beating into shape in order to get them ready for distribution to supervisors and operators on the shop floor. Often it's not even that high tech. Often it's a whiteboard. The key scheduling for the bottleneck operations takes place on a whiteboard, and then people look at the whiteboard and they understand what needs to happen at the bottleneck operations, and then everybody else just infers what they need to do upstream and downstream of that. But after launch, you have the scheduling engine in place, the ERP system and the MES system, and the production control team. This system, an advanced production scheduling system, does not replace a production control team. It aids the production control team in many ways, but it does not replace them. That's a very important point.